So in this video, we're going to talk about radical expressions. But what I really want you to get out of it is the fact that these aren't any different than exponents. Radicals and exponents share all the same properties. So for example, here, instead of writing it as as a radical, I'm going to write it as an exponent. So a to the m, and then I'm going to raise that to the 1 over n power, since we learned that that's the same as the nth root. Well, if that's the case, that was a to the m, then I can use my exponent rule and multiply those exponents together, leaving me with a to the m over n power. That's it. Nice little trick. And sometimes it's going to be beneficial for us to write them this way. But in general, exponents are easier to work with than radicals, so I encourage you to convert them up. Now, let's look at another instance of radicals and how we can use exponents to understand them. So we've got square root of 3 times the square root of 7. Well, I know I can rewrite that as 3 to the 1/2 times 7 to the 1/2. Well, we learned earlier that I can then group together the 3 times the 7, since we have 1/2 of each of them, okay? And then I can multiply those together. And lastly, if I want to, I can convert them back into a square root or a radical. Well, that allows us to see a really interesting little shortcut, and that is that if I have a square root times another square root, or a cube root times another cube root, or any of the same roots or radicals, then I can just multiply together those bases. Works out pretty well. It's just the same as exponents, in fact. Let's talk about conjugates. First off, they're not unique to radicals. You've seen them before, something like this. Okay? Now, if we go ahead and multiply that out, we're going to see an interesting result. This is just equal to 0x. As it turns out, what happens is that middle term just goes away, and we're only left with our second degree term and 0 degree term. We'll talk about what I meant by that a little bit later if you don't know. So why do we care about this? Well, because radicals can have conjugates too. And in fact, when we start talking about complex numbers, it'll be important for us to understand them. So let's look at one. Okay, you'll notice it has that same pattern, 2 plus the square root of 3, 2 minus the square root of 3. Okay, and it has to look just like that. If it was something like 2 plus the square root of 3 times 3 minus the square root of 3, that's close, but we're not going to get that relationship where that middle term drops out. We're not going to get those opposites in the middle. Okay, but when we multiply this out, something interesting happens. Okay, again, that middle term becomes 0. And the square root of 3 squared is just 3. So what happens is we don't have a square root anymore. The root goes away. Okay? And that becomes, again, important with complex numbers. And there's also something called rationalizing the denominator. And if you'd like to, you can kind of complete this problem here. I'm just going to set it up. But there's plenty of examples of this online. Okay? And it's frankly really archaic. But what happens is, if we multiply by the conjugate, the same thing that happened up here is going to happen, and our denominator is no longer going to have a square root in it. It's really not that important now that we have calculators, but it's a skill that you may or may not need. You can always look it up online.